So we were working on the integrated diagnosis task 3, and we are a team of 2 members, Sajid and Tomé, and our team name is Tabular Muggles. So the overview of the today's task, and then later we understand the data set, and then the data formulation, the methods and results, and the future direction and the final remarks of our work. Then the first thing is to understand was the importance of integrating diagnosis. Now, when we go to the hospital, there are multiple tests are conducted by the physician. And when now a human being take a lot of input to diagnose something, then why we should train a machine learning only using a single data set. So now the challenge is to combine a different sets, different distribution of data, and how to combine them and what is the benefit of combining those different data sets. The one benefit is that we can get the more accurate model, and it could be a more generalized and robust. Now the data set given to us, it's a mix of textual data and categorical data. As you can see, we have three different data set: the blood values, the radiology, and the temperature. The blood values has 19 features, and they are at different time steps, whereas the radiology is just the textual data, true and false. And we have a temperature readings, that's also a time series data, and the output is the 3 class labels, 3 columns label. The training samples, 1,000, validation and testing are each equal to 250. Now the biggest challenges is that we have to combine these different time steps modality. And as you can see, the radiology data is a very scarcity, like from 0 to 57, and the rest we don't have any data set. Whereas the blood values are 0, and then there are missing values in between, and then 89. For time being, we just take the mean of all these things. So we just consider baseline data, we take the mean of our blood values, and now the radiology is the textual data. So we cannot take the mean or standard deviation, something like that. So we assume that, and that the last reading is more recent reading. So we just consider the last reading in the radiology data, and the temperature is the mean, and then the output. So we have a total of 28 features. And in the approach 2, we also consider the standard deviation in addition to the mean. And then now this is the 3 column labels classification. So we just use like a different encodings, like a 7 multiple labels we have given. And okay, now from here, my teammate will take care from here. Yeah, please, Tommy, you can continue.
Yeah, sure. So for this task, we use the XGBoost. Maybe all you know, this is a very used algorithm. And then we have here our hyperparameters if you want to train to. Yeah. So basically, we start with the multi-class, the 7 different labels. We have here the results for them. Basically, the first results for the baseline are very poor. Basically, we have an accuracy of 17, which is very, very low. But we try to find what are the most important features that we have. So we printed the sharp value graph, and then we see some of the most important features. So, and we think about these features, and we try to add the standard deviation, not only the mean, but also the standard deviation, and we see a improvement on the model. Because if you think about, we have now a range of values that these features can have, and this is very important for the model. Basically, we are introducing some time dependence for the model. For the binary task, we also do the same. Basically, we have firstly only the mean values, and the results are around the 60. And after we add the standard deviation values, basically the results improve, yes, a lot again. Yeah. So as you can see in this figure, the CHAP value, there are several features that are most important than the others for the decision, like urea, like thrombocytes, phosphates, and so on. So as final remarks, this model proved to be a good choice for these tasks. We want to try other models like MLP and other kind of stuff, but we don't have much time. But I think we must do some also more preliminary studies using, for example, just unimodal data for the model and then see the difference between the unimodal and the multimodal. We didn't do that, but I think it's important to know what's the advantage of using or not the multimodal input. So in addition, I think we can also compute other time domain features like using the variance, the max, mean. We can also have other type of features and then retrain the models and see what happens. And I think that's it. Thank you for your time.